Hi everyone, welcome to the study of this nice ODE, which is linear and of the second order with constant coefficient. You are given second derivative of y is equal to, second derivative of y with respect to x plus 7. First derivative of y with respect to x plus 12 is equal to 0. So, we are going to seek an equation of the form y is equal to c1 exponential m1x plus c2 exponential m2x, whereby m1 and m2 are the real root of this ODE, and the c1 and the c2 are essential arbitrary constant. So to solve this one, we are going to let our y be equal to exponential mx, and we are going to get our y prime be equal to dy over dx, and also we are going to let our y double prime be equal to second derivative of y with respect to x squared. So we are going to find our ym prime. You differentiate exponential ym, exponential mx to get m exponential mx. You differentiate it again, so you will have m times m, which will give you m squared exponential mx. Once now you have obtained your y prime and your y double prime, which is equivalent to dy over dx, y double prime, which is equivalent to second derivative of y with respect to x, you substitute them in your given ODE. So you are going to substitute them in our given ODE to obtain the following: m squared exponential mx plus 7m exponential mx plus 12 exponential mx is equal to 0 after substitution. So we can factor exponential mx to be left with m squared plus 7m plus 12. This is giving you 0. Then from there, we note that the possibility we have here is that exponential mx cannot be equal to 0, which implies that whatever is in the bracket, it is the one which is equal to 0. So m squared plus 7m plus 12 is the one which is equal to 0. And this is a quadratic equation whereby we have our product. Our product of this quadratic equation is equal to 12. The sum is equal to 7. So we find the factors of 12, whereby we have 3 and 4. We ask ourselves, what are the two numbers which when you multiply you get 12, and when you want you get 7? Yeah. So it is 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. And both are positive. So you use them here to factorize our quadratic. So we will have m squared plus 3m plus 4m plus 12 is equal to 0. Here we can factor m. In the first pair, we factor m to be left with m plus 3. Plus, we can factor 4 in the last two pair, m plus 3, which is equal to 0. So, m plus 3 is common, so you will have m plus 3, then m plus 4, which is equal to 0. This tells you that either m plus 3 is equal to 0, which implies that your m1 is equal to negative 3. Also, you have m plus 4 is equal to 0, which implies that your m2 is equal to negative 4. Now, we understand that our equation will take this form: y is equal to C1 exponential M1x plus C2 exponential M2x, which is equal to, we can substitute our M1, C1 exponential negative 3x plus C2 exponential negative 4x. So that is our general solution, which we can use to check. So our general solution is this one. Y is equal to C1 exponential negative 3x plus C2 exponential negative 4x. That is our general solution. Now, you can always check whether it is correct from the given ODE, whereby now you get your y prime. You differentiate this equation, you will get negative 3c1 exponential 3x minus, this will give you negative 4c2 exponential negative 4x. Then you can get your y double prime, which will give you 9c1 exponential negative 3x, then plus 12c2, this is 16, sorry, 4 times 4 will give you 16, negative, and the negative will become positive, exponential negative 4x. Then you substitute these two to the given ODE. Our ODE is y prime plus 7 y double single prime plus 12y is equal to 0. So we substitute, you will have 9. You shall have 9 c1 exponential negative 3x plus 16 c2 exponential negative 4x. The next is 7 times negative 3. That will give you negative 21 c1 exponential negative 3x. Then you have negative 4 times 7, which will give you negative 28 c2 exponential negative 4x plus c1, not c1 but 12. We are substituting here 12 c1 exponential negative 3x plus 12 c2 exponential negative 4x. Then the next thing is to group the like term together. You group the ones which have 9c1 exponential negative 3x. So you have 9 minus 21. And then you have also 12. So 9 plus 12 is 21. 21 minus 21 is 0. Then plus, you have 16 plus 12, which is here. 16 plus 12, the one with the C2, which will give you 28. 28 minus 12 will give you 0, which is equal to 0. So meaning that our working is correct. So the solution of the given ODE is this. And then the auxiliary solution is equal to y is equal to c1 exponential negative 3x plus c2 exponential negative 4x. So thanks so much for taking your time to study with me on linear differential equation with the constant coefficient of the first order. For more examples on that topic, check in my YouTube channel. Also, if you have not yet subscribed, kindly consider to do so that you don't miss a single video which I upload for us. On this topic, also, I have provided the link below to see various examples which I have done for us. Thanks so much for your support as we continue learning this important field of applied mathematics.